So let's suppose that my load ZL is somewhere here. And this is the impedance Smith chart that we actually discussed last time. So hopefully you can all very quickly read the normalized impedance of this load just by the point that I actually put on the Smith chart. So if you look at the real part, it's actually going to be equal to 0.2. And if you look at the imaginary part, I'm on the lower side of the Smith chart, so it's certainly a negative sign. And it's basically intersecting this part of the circle right there. So it basically has a negative 0.5 reactance. So let's suppose that I don't like this reactance, and I want to change that to this reactance right here, basically positive J2, J.02. So I want to basically start from ZL, and I want to end up with this Zin. So if that's the case, if I don't really want to change the real part of the load, it's actually pretty straightforward to think about this as adding a series inductor, since I'm only basically changing the reactance of the load. So I'm going to basically move on a circle that has the same constant real part right here, and I'm going to basically add a reactance. So I'm moving along this part here. And so the question is, how much of an inductance should I add? Of course, the inductance has a reactance of Jx, so I'm really looking for what is this x. That's pretty easy to do. So Jx should actually be equal to J.2, which is what I want to end up with, minus my beginning, which is negative 0.5. So obviously, this is equal to J.7. So that means the reactance that I need to add is clearly 0.7. And if I really want to find out exactly what is the inductance that will yield this reactance, then this will be equal to J omega L, obviously divided by Z naught, since we're talking about normalized values. This will be equal to J.7. And if you do know the frequency omega, and if you do know your impedance Z naught, this equation will immediately tell you how much inductance you really have to add. So this is a pretty simple but useful calculation of essentially seeing how we move on the Smith chart if we change basically the real or the imaginary part of the load. Here I showed you only how to change the imaginary part of the load by adding a positive reactance. Of course, you can easily see what would have happened if you have added a negative reactance. You would have moved basically here. Or if you had basically added an actual resistance, you would basically have moved somewhere here. So dealing with series loads is pretty simple since you already have the circles of constant resistance or constant reactance on the Smith chart.